Okay, now we're going to learn how to find the area of triangles that are not right, oblique triangles. And so here is oblique triangle. It is not a right triangle, but we know that what's easy about finding the area of a right triangle is that the altitude is right here. This is the height, and so this is the base. And so the area of any triangle is equal to 1/2 base times height. So the issue with triangles that are not right is that you have to drop an altitude and you don't necessarily know what that value is. So we're going to look at how to do this. So we know that the area of this is 1/2 base times height. So the base of this is B and the height of this is H. That's true. The problem is we don't know what H is when you have this. So what can we do? Well, we can, I don't want to call this A because A is also stands for an angle. I want to be careful here. This is the area. So the area is 1/2 base times height. So we have the base here, B, 1/2 base. But the height, how can we figure out the height? Well, there's a few ways because we know about sine and cosine function. Because once you drop that altitude down, you have two right triangles. You have a right triangle here, you have a right triangle here. So let's see. What if I take the sine of angle C? Well, that's equal to opposite, which is H, over hypotenuse, which in this case would be little a. What if I take the sine of angle A? Well, if I look at this right triangle here, the sine of A is H, opposite, over hypotenuse, which in this case is C. So I can solve for H in both of these equations. H is going to equal to here A times the sine of angle C. Here, H is going to equal to C times the sine of angle A. Now, this is a little c, and this is big C, the angle C. So I made it look weird, but that's the big C. Okay, so we can come up with a couple of formulas for area. Area is 1/2 the base B, right, times the height. So it's 1/2 B times C times the sine of angle A. It's also equal to 1/2 base times the height, and I could use this, B times little a times the sine of angle C. Also, if I decided to drop an altitude here, that doesn't look like I did a very good job dropping an altitude, but I could drop an altitude there and draw another right angle. I could get more expressions. In that case, this would be the base and this would be the height. And so we could come up with more expressions for the area. And so what you'll find if you were to do that, follow through, is the area would also be equal to 1/2 A times C times the sine of angle B. So what you can see here is a little pattern you can pick up on is that the area of an oblique triangle is equal to the length of two sides, 1/2 times the length of two times sides times the sine of the angle in between. 1/2 B times C sine of A, or 1/2 B times A times the sine of C, or 1/2 A times C times the sine of angle B. So if you know two sides and the angle in between, you can figure out the area of that triangle. All right, so find the area of the triangle given this. Angle B is 42 degrees, A is 7.2 feet, C is 3.4 feet. Round the area to the nearest tenth. So I'm going to draw a generic triangle, label it A, B, C. So this is little a, this is little b, this is little c, and what they gave me was 42 degrees is B, and that little a is 7.2 feet, and that little c is 3.4 feet. So very nicely, they've given me two sides and the angle in between, and I can use the formula I just learned to find the area. So the area of this triangle is going to equal to 1/2 little a times little c times the sine of the angle in between b. So it's 1/2 7.2 feet times 3.4 feet times the sine of 42 degrees. And I will make sure my calculator is in degree mode. And I will say 1/2 times 7.2 times 3.2 times the sine of 42 degrees. And I round to the nearest tenth. I'm going to get that the area is equal to area, not angle A, is equal to 8.2. And this is a foot times a foot, square feet. All right. Now, this next one's an interesting problem. Find the altitude, which means the height. Okay. Find the altitude of the aircraft shown in the figure. Round to the nearest tenth of a mile. So we have this triangle here, and this altitude is our height. Okay. And they gave us this distance here, which is 20. All right. So if I label this A, and I'm going to because they have that little a there. And I'll label this one C. This will be little c, and this will be b, and this will be little b. All right. Then what I need to know is this h. So I could say that the sine of this angle A is h over c, or the sine of this angle 15 is h over a. But the problem is I don't know what a is and I don't know what c is. But I could remember that the area formula, oh no, I can use the law of sines to get there. I'm sorry. I'm going to use the law of sines to get there. I know I can figure out this angle pretty easily. 180 degrees minus 15 degrees minus 35 degrees is what angle B is going to equal to. And that is equal to 130 degrees. Okay. Now, if I know that that's 130 degrees, then I'm in good shape. I can use the law of sines to figure this out. So I need to know, I can't figure out H directly from that, but I can figure out either A or C. I guess I'm going to figure out A. You could do either one. It doesn't matter. So I'm going to say, little a, which is what I'm trying to figure out, is to the sine of 35 degrees as little b, which is 20 miles, is to the sine of 130 degrees. And I can cross multiply here, and I'll get a times the sine of 130 is equal to 20 times the sine of 35 degrees. If I'm solving for A, I'll divide both sides by the sine of 130 degrees. And I'll get that A, little a, is equal to 15 to the nearest tenth is 15.0. All right, that's good. Then if I know A, then I'm going to use the triangle on this side because that's what I solved for. If I had solved for C, then I would use the triangle on that side. And I'm going to say, you know what? The sine of 15 degrees is opposite h over hypotenuse 15. So the sine of 15 degrees is opposite h over hypotenuse 15. So h is equal to 15 times the sine of 15 degrees. And that is, to the nearest tenth is 3.9. And so that is the altitude. That's how high the plane is. The altitude is 3.9 miles, the altitude of the plane. All right, so that's how you can use signs and law signs to find the area of the triangle. The next video we're going to look at is Heron's formula, and that's how you find the area of a triangle if you don't know any angles at all, but you know the lengths of the sides. Okay, that's next.